Hey there! Welcome to the Physics Bomb Girls Home Base Experiment number 1, all about electrostatics. To begin the experiment, Josh and Chelsy will start with the first demonstration.
Rub the balloon back and forth on your head 5 or 6 times to triboelectrically transfer negative charge from your hair to the latex of rubber balloon. When balloons are rubbed in head, the hair stick on the balloon producing a static electricity as they glide to one another. Due to the transfer of electrons to the balloon, it making it negatively charged and attracted to the positively charged hair. The type of charging it persists is friction.
Charge the balloon by rubbing until it is able to attract a piece of paper or any other material you can think of. When the balloon is brought near the pieces of newspaper, the negatively charged balloon attracts the positively charged electrons. Since positive and negative attract, the paper will move towards the balloon. Therefore, the negatively charged balloon attracts the newspaper.
Next, we will now observe the plastic shield rubbed with silk cloth. We observed that when the plastic shield was rubbed against the silk cloth, both objects exhibited an attractive force due to transfer of electrons caused by the friction that occurred. This type of charging can be labeled as charging by friction.
Next activity is rub plastic shield held by palm then touched on silk cloth. We have observed that when the rubbed plastic shield is held by the palm of the hand, it persists a warm feeling due to the friction created. The rubbed plastic shield and silk cloth are attracted to one another. This type of charging is charging by friction.
For the next activity, we need to have two pieces of about 1 inch Scotch tape. For the first part, we tape both of them on a clean table and then we move at the same time. Bring them near each other. As both Scotch tapes were pulled from the table's surface, they carried some electrons with them and becomes negatively charged. When brought together, they repel each other because they have similar charges. The transfer of electrons was acquired through contact. That means that the type of charging mechanism observed in this activity was the charging by conduction. For the second part of this activity, we need to tape one piece on top of the table, then tape over it another piece of the Scotch tape. Remove from the table and separate them. As the top and bottom pieces of Scotch tape were separated, the former began receiving electrons from the latter. As a result, the piece tape on top of the table is more positively charged than the one put above it. Because the tapes had opposing charges, an attractive force was observed among them. Again, the transfer of electrons was acquired through contact. That means the charging by conduction was observed.
Get 2 plastic cover sheets. Bring one plastic cover near the other sheet. Both uncharged plastic covers will repel when they are in close proximity.
Lastly, one charged plastic cover brought near to uncharged plastic cover. We have observed that a charged plastic cover will attract an uncharged plastic cover when they are in close proximity. This type of charging is charging by induction.
For the demonstration of Coulomb's law, we need to connect 2 sheets of plastic cover with about 5 cm string. Then, we charge both of them using a newspaper and hang them using any long cylindrical or rectangular object, just like the tumbler and the ruler as shown in the video. In order to calculate the electrostatic force between the 2 sheets, the formula for Coulomb's law as displayed on your screen right now was used. F represents the electric force that the charges exert on one another, or simply the calculated electrostatic force. K is the Coulomb's constant, which is equal to 9.0 multiplied by 10 raised to the power of 9. Q1 is equal to the charge of particle 1, while Q2 is equal to the charge of particle 2. In this activity, it is considered that the value of electron charge, which is equal to 1.602 multiplied by 10 raised to the power of negative 19 coulomb, as the charges of the 2 sheets. Lastly, R is equal to the radial distance between interacting charged particles, which was initially measured as 4 centimeters but was then converted into meters. After substituting all the given values, the calculated electrostatic force between the 2 sheets results in 1.44 multiplied by 10 raised to the power of negative 25 Newton.
For guide question number 1, Recalling the interactions between like and unlike charged objects that you observed before, can you explain your observation? Coulomb's law was clearly observed all throughout the experiment. According to the law, like charges repel each other, unlike charges attract, which means that negative charges repel each other while a positive charge attracts a negative charge. For instance, the balloon used in the experiment becomes negatively charged while the hair becomes positively charged. Due to opposite charges, an attractive force was observed between them. This is also due to friction, which occurs when electrons are transferred from one object to another when they are rubbed together. On the other hand, like charges repel notion from Coulomb's law was observed in the experiment of two separate pieces of Scotch tape that were brought in contact. As they were both pulled from the table, both pieces of Scotch tape becomes negatively charged, thus exhibiting a repulsive force.
Guide question number 2. An object has a charge of 1 coulomb. How many electrons does it contain? For this problem, we will be using the formula Q equals NE, where Q is equals to charge, N is equals to number of electrons, E is equals to the charge of 1 electron. Since we are asked of the number of electrons, what are the number of electrons, we will modify the formula, then it will be Q over E equals N. Substitute the given, where Q is equals to 1 coulomb and E is equals to negative 1.6 times 10 to the negative 19. It will be 1 over 1.6 times 10 to the power of negative 19 equals N, which the final answer will be 6.25 times 10 to the power of 18 electrons.
Thank you for tuning in to our video. The Physics Bomb Girls hope you learned something new. Again, these are my group mates, Miss Chelsy Giban, Miss Andrea Palenzuela, Miss Kate Tomas, Miss Jasmin Valentin, and me, Miss Maxine Obciana. Goodbye, and I hope to see you again soon.